The application used in this demo is a polyglot microservice-based e-commerce application consisting of a front end based on Node.js, a shopping cart and order processing service based on Python, a product catalog and user authentication service written in Golang. The state of the cart is retained in Redis. Orders depend on a payment service, and data for orders, products, and users are persisted on MongoDB. To improve the resiliency of this application, we deployed it on 2 clusters and can manage and observe both application instances with the Global Namespace and Tanzu Service Mesh. The Global Namespace is used here as an application boundary construct. To start tracking the health of our application, we create an SLO policy. This SLO isn't just a note in a service definition document or tracked on a spreadsheet. It is built into Tanzu Service Mesh. It can be scoped to a global namespace and have multiple SLIs. The objective is tracked as %time healthy over the calendar month. It can also track multiple services. Here we see the SLO tracking our currently healthy application. Based on the selected time range, we can see how well the service is meeting the objective over the period. We can expand the SLO to see how the error budget and SLIs are trending as well. When an SLO is scoped to a global namespace in Tanzu Service Mesh, it tracks the health of all instances of the service regardless of which cluster or platform it is running on. Here we see our shopping service being tracked on 2 different clusters in the same global namespace or application boundary. Due to a recent flash sale, the number of users this application has increased significantly to the point that it has become completely unresponsive. So how does this scenario appear in Tanzu Service Mesh? Looking at this time lapse, we can quickly see the health of the service is not meeting the objective on the SLO status bar. The latencies are worsening at the peaks of the traffic, which is causing the service outage. Let's test using an autoscaler. Autoscaling policies in Tanzu Service Mesh can also be created in the global namespace construct. This autoscaler has multiple modes, sources its metrics from Tanzu Service Mesh, has adjustable metric windows, independent scale up and scale down conditions, and with actionable SLOs, more data is used for scaling decisions. Let's test this first by putting it in simulation mode. With the simulation mode, the autoscaler reports if and how it would scale a service based on the runtime metrics defined. Here we see the same traffic pattern as before, and the Tanzu Service Mesh autoscaler recommending an increase in the instance count. Let's activate the autoscaler by editing the configuration. Just go to the Activation tab to toggle the activation. With another wave of the same traffic pattern, we see the autoscaler increasing the instance count and the health of our service is staying green. By autoscaling, we are meeting our objective while efficiently using compute resources. Our application is healthy again and keeping up with a surge of new users. So what have we learned here? With Tanzu Service Mesh, we can use SLOs to track the health of services in distributed applications. We can create auto-scaling policies on a global namespace, and we can understand how to scale our distributed services with the autoscaler simulation mode.